Good morning. This is our last lesson for our probability unit. Um, so there is some practice that we'll be doing next week before our final. But as far as instruction, this is the last piece of instruction you're going to receive. Again, if you are on quarantine, I will not expect you to do the quiz until you return and you get to ask your questions and we get to check in work and things. Um, But today we're doing dependent events. Yesterday was independent. Today is dependent, where one event depends on another. Okay, so when we were talking about coin flipping, or actually more like pulling things out of a bag, it's like you pull out marbles from a bag and you don't put the first one back. So if you start out with 6 marbles in a bag and you choose one, all of a sudden you only have 5 in there. Not all of a sudden, but you only have 5 in the bag. So now your probability completely changes because you're starting with a different total. Okay, so that's how dependent events work. So when the outcome of one event impacts the outcome of another. So with independent events, one outcome did not affect the other. But with dependent, yes, they are related. Okay, so we're going to look at these, and Edpuzzle is back up and working. So this would be an Edpuzzle for you today. So 1 through 5, you're going to determine if it's independent, if they depend on one another, or if it's a dependent event. Okay, so when we're looking at flipping 2 coins results in one landing on heads and one landing on tails. Okay, so there are 2 coins, you're flipping them independently, so it's an independent event. The captain of the football team is selected, and then the co-captain is selected. Well, the captain cannot be the co-captain, so it's dependent. You draw a joker from a deck of cards, and then you draw an ace. It doesn't say I put it back, so that is dependent. If I had replaced that joker into the deck of cards, then it would be independent, but it is not. Oh, look, you draw a queen from a deck of cards, replace it, and then draw a 10. So that's independent. We're starting with the same deck of cards. In number 3, doesn't spell that. In number 3, um, it's like we are drawing from a brand. No, we have changed the deck of cards when we make our second selection. But in number 4, it's like we're drawing from a brand new deck. A coin is flipped and a number cube is rolled. Those are independent. So we're going to move down. We'll go through these formulas again. So when we had probability, independent probability, we just went ahead and we multiplied those probabilities together. What's the probability of event A multiplied by the probability of event B? When we're talking about dependent probability, we start with the probability of that first event. Like, let's look at the deck of cards. Joker from a deck of cards, then draw an ace, right? Well, drawing an ace is going to look a little different because we're going to have less cards. So instead of 52, we have 51 now. So the probability that we multiply it of is not just B, but B after A occurs. We look back at this joker, probability of pulling the joker was 1 out of 52. But the probability of drawing ace Oh, it's 4 out of 52. But now the probability of drawing an ace is 4 out of 51. Okay, so you have to think about what we did not put back in to that deck of cards. Okay? All right. So yesterday we saw some independent events that looked like this. The bones and the colors and the balls. And this one was about Mackenzie and the candles. Okay? So number 6 says Neil goes to the pet shop, selects a treat for his job. He chooses one and chooses another. What is the probability that Neil selects a bone and then a ball? And then, the very important word there. Okay? So we're going to walk through these two together. And then we're going to work on some ed puzzles for the rest of them. Okay, so a bone. So there's 1, 2, 3 bones. So my probability is 3 out of 6 for the bone. Now he keeps it. So that bone is gone now. So I have 1, 2, 3, 4, 5, 6. Oh, there were 7. 3 out of 7. So now there's 6 left. And then your ball. So 1, 2, 3, 4, 5, 6. There's a probability grabbing a ball is 2 out of 6. Okay, so we just multiply across. I'm going to see if I can reduce before I multiply, though, and I can. So 2 6 is equivalent to 1/3. And then I can also reduce a second time, 3 and 3. So I'm going to multiply straight across now. 1 times 1 is 1. 7 times 1 is 7. So it's 1/7. So again, with these probabilities, your final probability should be smaller than the combined the individual event probability. Okay. All right, let's look at Mackenzie. Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? Says nothing about replacing. And then chooses another. Okay? So what is the probability that Mackenzie is going to choose these polka dots? So there are 1, 2, 3, 4, 5 to start with. So there are 2 chances that she chooses a polka dot. Now we have to imagine she chooses that polka dot the first time. She doesn't choose any other random because we're just asking about polka dots. So that one is now gone. So I have 1, 2, 3, 4 candles left, and she chooses the other polka dot. There's only 1/4 chance to choose it the second time. I'm going to try to reduce before I multiply. So I see this 2 and 4 is equivalent to 1 and 2. Divide them both by 2. So I multiply straight across 1/10. There's a 1 out of 10 chance that she chooses the polka dot both times. Okay. So read each situation carefully. Determine if the events are independent or dependent, and find the probability of the events occurring. Okay? So we are going to be looking at this set of clothing. So the first thing I see are a few sets of pants, a couple skirts, one shirt, beach towel, lots of socks, or maybe that's a bath towel, and that is her laundry basket. So let's go ahead and look at what we're dealing with. What's the probability of selecting a top and then selecting a bottom? What's the probability of selecting a striped sock, replacing it, and then selecting another striped sock? What's the probability of selecting a towel, replacing it, and then select another towel? And what's the probability of selecting a skirt and a top, one choice after another? Okay, so the first thing I was supposed to determine is whether these were independent or dependent events. Okay, we're just going to go through. Video's going to pause. You're going to determine which one of these are dependent and independent. Okay, so you should have chosen 9 and 10 as dependent. And then 8 and 10 is independent. And I've underlined some words to help us figure out which ones are dependent and independent. So for independent, and then after another, for dependent, we have replacing it or putting something back. We saw yesterday that there were a lot of words like, let me go back. What are the ones we were looking at yesterday? Returns it. See, so returns it, replaces it. That's when you are going to see those independent events. Okay, so we have 4 questions to get through. Oh, wait, 5. What's the probability of selecting a matching pair of socks? One choice after another. That would be independent also. Okay, so we have to count up this laundry to start with. So we have to figure out the total number of items she has and count the socks separately. 16 items, okay? We're looking for a top and then a bottom, okay? So this is independent, so I have to remember that after I write my first probability, my second total is going to change. So I'm always starting with 16, but then I'm taking an item out. So top, there was only one top. So now for my second event, a bottom, I have the top in my hand, so there are only 15 items in there. But since I'm looking at bottoms, I don't have a top in my hand, so I will count both sets of bottoms here. So I'm going to reduce before I multiply. So divide these both by 2 and you get 1 and 8. Multiply this across. You get hold on just a second. Oh, hey guys. Alright, so selecting a bottom, not just this pair of slacks. Ms. West really needs to learn how to count. 1, 2, 3, 4, 5. 5 out of 15. Okay, and we need to reduce that before we multiply. So 5 out of 15 is 1/3. Let's multiply that across. 1 times 1 is 1. 6 times 3 is 42. So it's a 1 in 42 chance that she selects the top and then selects the bottom. All right. Let's try this dependent event, and then I will want you guys to do 10, 11, and 12 on your own. Okay. What's the probability of selecting a striped sock, replacing it, and then selecting another striped sock? Okay, so let's figure out there's 16 items. How many striped socks are there? 1, 2, 3, 4, 5. There are 5 striped socks. So 5 out of 16. And now I put that back. So my total is again 16 because I put it back. And since I put back that striped sock, the probability is still 5 over 16. Now neither of those are going to reduce, so we have to multiply straight across. 5 times 5 is 25, and 16 times 16 is 256. So those are my chances of drawing a striped sock, replacing it, and then selecting another striped socks. So you've got 10, 11, and 12 here. I'm going to leave the picture up here while you go ahead and do your add puzzle. All right, this is another dependent event. So probability selecting a towel, replacing it, and then selecting another towel. Oh, there's only one towel, and there are 16 items. So since it's dependent, I know I'm going to put it back. I'm going to use 1 out of 16 for selecting a towel, and then I'm going to use 1 out of 16 for selecting a towel again. So my probability is 1 out of 256. All right, number 11. What is the probability of selecting a skirt and a top one choice after another? This one is independent. So let's go ahead and see what the probability of a skirt is out of, because skirt is our first choice. So it's our first event. So there's 2 out of 16. So now I have the skirt in my hand. So my new total items is 15. Let's see, and then she's going to select a top. Oops, too far. And there's only one top. Is 1 out of 15. Okay, so I can reduce before I multiply. So I'm going to reduce that 2/16 to 1/8. Divide them both by 2, get 1/8. Now I can multiply across. 1 times 1 is 1. 8 times 15 is 120. Okay. Last one. Think about what you answered. What is the probability of selecting a matching pair of solid socks, one choice after another? So again, this is independent. This time we're looking at solid, not striped socks. Let's see how many solid socks there are. 1, 2, 3, 4. Okay. 4, and there's 16 total. Okay, let's go back up and act like I chose one of these solid socks. There. So now I have 3, and there's 15 items. Okay? So my chances of choosing one again, now 3 15s. It looks like I have a lot of reducing to do. Simplify these fractions. 1 over 4. Divide those both by 4. 3 and 15. I can divide those both by 3. I get 1/5. So my probability of getting that pair of solid socks is 1 out of 20. Okay. So I guess the moral of the story is just look at your laundry before you start grabbing things out of it. All right. So now your homework, which I will expect you to work on today. You've got 9 problems again based on these number cards. I want you to remember these are all going to be independent events just from the directions up here. So you don't have to choose whether it's dependent or independent. I'm telling you now these are all dependent events. So do not replace it. Then draw a second number, okay? And then this again is an independent event down here, okay? Because that's what we're practicing. Dependent event, because that's what we're practicing. Okay, so this will be a CAMI assignment. Go ahead and work on that and hand it in today.